Yes, Rasmi, you there?
Yes, ma'am.
All right. So, see, this was the assignment which you were given. And see, two assignments you've submitted. One was from the fifth chapter. So,
Yes, ma'am.
we discussed that in that chapter, the portions that you've written were well. It's just that when you're explaining no, the terms related to magnetism and all, just make the figures as well. The way you've explained it for the magnetic axis and all, when you were explaining the bar magnet, draw the figures for the magnetic field properties also, like for the attractive one, for the it is the directive one and all. Okay, that was fine. And from the second assignment, same thing. When you did this third question, for this question also, try to make up the figures. How are you subtracting it? You didn't show any direction of the force. You just subtracted them. Why is it, right? Like in this question, this is fine, even if you don't. But here, this question is all about the directions. Why are you able to subtract it?
Hello, ma'am. Can you hear me? In between, it's got
Yes, yes, yes.
cut.
Now are you able to see?
Yes,
Your
ma'am.
videos are also off from since
Yes, ma'am. I'll
time
turn
back.
it on.
See, in the class, you have to open up the cameras. If there is any specific issue, just tell me in the starting of the class. Then I'll not ask you.
Okay.
Okay. I was saying for the first question, it's fine. But for the third question, why have you subtracted it? It's because of the direction. So you need to show that yes, the directions are present and you are subtracting it. Okay. So you have to show that for every force, you will have to show the direction. So for that, you need to draw the figure in the third question. Okay, because your
Okay, ma'am.
marks will be cut. Like, why didn't you consider the other two sides? So
Yes.
that would be only visible, and that mentioning about the other two sides is also needed. Okay, now coming to question two,
Ma'am.
you had a doubt on question two, I believe.
Yes, ma'am.
Hey, it's not very difficult. This says that a current balance or ampere balance is a device for measuring current. A current balance or ampere balance is a device for measuring currents. So ampere balance, current balance means this is ammeter. Device for measuring currents. So current to be measured is arranged to go through two long parallel wires of equal length in opposite directions, one of which is linked to a pivot of the balance. Now resulting repulsive force on the wire is balanced by a suitable mass in the scale pan hanging on the other side of the pivot. In one measurement, the mass in the scale pan is 30 grams. The length of the wires is 50 centimeter each, and the separation between them is 10 millimeters. Okay. Now, look here. The question is very easy. Two wires are present. Okay. When two wires are present, they have a certain amount of current flowing through them. Let's say I1, here you have I2. Separation between the wires is also given, and there will be a force that we'll be calculating. Force per unit length, I think here will be required. Equal lengths are there. Mass is given, length of wire is given each one. You have to calculate the force because length of the wires are given. So full you'll have to calculate. Okay. So this will be the F mu naught I1 I2 divided into L divided by 2 pi D. This is what we have studied. Now it
Yes,
says
ma'am.
to balance this force, there is a mass put. So when mass is put, see, when we are talking about this mass downwards, there will be a gravitational force mg. And above this mass, the system is like this. The wires are present, and on the top of it, this is it. So the wires have the force like this. This has mg. So basically, your second force will be this m into g. So what you can do, you can just equate both these forces are balancing because that is what the question clearly said. We didn't assume, right? It said the resulting repulsive force on the wire is balanced by the mass in the scale band. Okay, so m is given, g is given, length of the wire is given, current is missing that we have to calculate mu naught by 4 pi you already know, and small d is given as 10 millimeters. I'll just write down what all things are there. Look, length is given as 50 centimeter. So you can just write it as 0.5 meter. Currents are same. So this formula will become, I'll tell you this. D is given as 10 millimeter. So 10 to the power minus 2 meter. Yes.
Yes, ma'am.
1 minus 3 is minus 2. And we here L and D were only required. Mu naught by mu naught, you already know it's 4.10 to the power minus 7. Mass is given as 30 grams, so you can write it as 0.03 kg. And G is to be taken as 9.8 meter per second square. This will be 0.03 kg. Okay, now look, when you are equating it, current is asked in the question. You can simply say, see, this becomes 2 into 10 to the power minus, or I'm just writing the variables, values you can write and then solve. See, here in this question, we can simply say, this will be mu naught. I into I means I square L 2 pi D is equal to mg. So from here, current will be equal to mg into 2 pi D divided by mu naught L under root. This much of ampere will be the answer. Put the value, see what's the answer coming. Okay.
Okay, ma'am.
Right. Now is your doubt clear for the second question?
Yes, ma'am.
All right. Please write it. Now,
Ma'am, is 280 the answer?
how much are you getting?
280.
280. We'll have to check this. I think it will be a little less than 280. Have you taken 9.8?
No, ma'am. I think I made a mistake. I put M as 0.08, not 3. So it might be a mistake.
That's right. Okay, anyways, you can do it later. Let's come to the chapter. Do you have a class tomorrow, Basmi?
No, ma'am, but if you're free, I can join a class tomorrow.
No, I think you said Monday to Saturday, no? That's why I wanted to confirm. So,
Yes, ma'am.
see the next class then we'll have on Tuesday. Okay.
Okay, ma'am.
Let me complete this. So, yeah, we were at this magnetization vector. That was intensity. This was intensity of magnetization. Just add it somewhere in your notebook when you have written here, no? Intensity of magnetization. Okay. So that you know
Okay,
this
ma'am.
is what it is called. So this is basically the net magnetic moment per unit volume. Now, we did one question and then I discussed magnetic field intensity. So I told you when you have the internal magnetic field, that is your intensity of magnetization, and the magnetic field produced due to some external factors like the current carrying coil and also these are your magnetic field intensity. So net magnetic field is sum of the internal plus the external. So which we discussed and we had a conclusion that H is equal to B by mu naught minus I. So two conclusions we got. B naught is equal to mu naught H. B medium is equal to mu medium into H. That's what we've got. Now see,
Yes, ma'am.
this I is nothing but known as susceptibility. Okay. So for the susceptibility, we have one more formula. If I write mu r will be mu m by mu naught. And from this formula, tell me what will be mu m equal to?
PM the head.
Bm by h. And from here, mu naught will be equal to
C not by head.
mu naught by h. No, b naught by h. Yeah, right.
Yeah.
So this will be b m by h, while this will be b naught by h. HH get cancelled. Relative permeability now has one more formula getting added to your concept. Bm means magnetic field for a medium divided by magnetic field in air. Okay, but wait, mu m by mu naught, if I write it from here, mu m is equal to mu naught 1 plus chi, right? You'll have different values for this magnetic field for a medium, magnetic field for air, like this you'll have it for different materials. So in some materials the magnetic field increases due to relative permeability. Okay, I'll write this down also. This is a factor by which magnetic field increases on introducing some materials. Okay, so because of the relative permeability increases. Anyways, if I write from here mu m by mu naught, that will be nothing but mu r. I had one equation of mu m equal to mu naught 1 plus chi, right? 1 plus susceptibility. If I write mu m by mu naught, it will be equal to 1 plus chi. This is nothing but mu r. So relative permeability is 1 plus chi. This is an important formula. Got it?
Yes, ma'am.
Okay. So see how many formula you will have. From here you have the formula of H. Okay, then along with H, B naught and Bm will come. Then this formula relating it to this one, the same. Okay. Now we'll practice
Ma'am.
one question based on this, and then I'll move on to the types of materials, magnetic, diamagnetic, and all. I'll discuss it. I'll give you a typed and a more precise detailing of the content properly. Later on, I'll give you that. So you just understand the concepts in the class, and the material I'll provide you through WhatsApp. Okay, because that has
Okay,
to be
ma'am.
remembered by you properly. Write this, then I'll make you practice a question. Till here you have done from me.
Yes, ma'am. Ma'am, can you scroll down? Ma'am, I'm done.
Okay, look at this question. This says a solenoid has a material of relative permeability 400. Okay, if the solenoid has 1000 turns per meter and carries a current of 2 ampere, we have to get H, B net, and I, all these things. So, what all things are present? What is this?
Mu R.
Mu R, yes. And what is this 1000?
Capital N. No, small n.
Small n. And current is 2 ampere. So, we have what all things we have. Mu R is given as 400. Small n is given as 1000 and current is given as 2 ampere. This is the data that we have. Now look, we have to get in the first part the value of H, and it's a solenoid. What's the magnetic field of a solenoid?
Solenoid is mu 0 I by 2, 2 pi R, I guess.
This.
No.
You've done the assignments also based on this mu naught and I. Now see, then you have magnetic field as B naught was mu naught into H. Both of these magnetic fields are the same because this is the magnetic field provided by the solenoid, which is coming into
Yes,
action.
ma'am.
So we can say mu naught n I is equal to mu naught H. Mu naught can get cancelled. N into I. So that is 2 into 1000. So H is equal to 2000. What's the unit of H?
Uh, Not Tesla. It's a rate.
Ampere per meter.
Oh,
Okay? Ampere per.
yeah.
So this is H. Second part says the net magnetic field. See, for the net magnetic field, this will be given by the solenoid itself, right? You'll have it through the solenoid.
Yes, ma'am.
Okay. And third is I. So I was equal to
I was equal to I is current, so 2 ampere
first
itself.
tell me for the second part, Bm is equal to mu m into H.
Yes, ma'am.
How
So
can I write mu m?
mu m can be written as mu R mu 0.
Yes, mu r into mu naught into H. Right? Now mu naught, we already know mu r is given in the question. So we'll get mu r is 400 into 4 pi into 10 to the power minus 7 into 2000. Right?
Yes,
So
ma'am.
this will be around this is 16, 32 pi something. If I write this as 32 pi, zeros will be, this is 5 minus 2, 10 to the power minus 2, right?
Yes, ma'am.
This much of Tesla will come. Now look, we have to get the net magnetic field, correct? This is Bm. B naught is how much? B naught will be mu naught into H. B naught will be mu naught into H. That is 4 pi into 10 to the power minus 7 into H
Yes,
is
ma'am.
2000, right? So we'll
Yes,
have
ma'am.
this as 8 pi into 10 to the power, this is 3, 10 to the power minus 4 Tesla, right? Now, when
Mm,
we use the net magnetic field, we'll have B naught vector plus Bm. Remember, we discussed this. I
yes,
made you
ma'am.
write also. So this would be 32 pi into 10 to the power minus 2 plus 8 pi into 10 to the power minus 4, where you can take other things also common now, right? 8 you can take common, 8 is common in, and between 32 and 8 both. What will be left then? If we take 8 pi into 10 to the power minus 2 common,
Will be 4 pi plus, no, 4 plus 1.
4 plus 1, that is 5, right? So 5 into 8 is, no, not 4 plus 1.
40.
10 to the power minus 2 will be left, no?
Yeah. 4 plus 10 to the power minus
See,
2.
if I take 8 pi into 10 to the power minus 2, 4 plus 0.01, right? 10 to the power minus 2. So this makes it 8 pi into 10 to the power minus 2 into 4.01. So
Yes,
something
ma'am.
like this, the net magnetic field will come. Yes, what is I vector? What is the meaning of it?
The total current flowing.
No, total current. When
No,
do we write vector signs for current? Look into the notes. Go through your notes.
whose
What
number
was
will I?
what was this I vector?
Um,
Hmm. In the last class you have written. Check the notes.
O M by V. Intensity of magnetization.
Yes. And what's the formula?
Magnetic movement by volume.
Yes, correct. Okay, so here you have to get the value of I. I is missing. Look, what all things we have done. This is your I, the intensity of magnetization or magnetization vector. Put intensity of magnetization right now in your notes before you
Mm.
forget it right now. Okay. Okay, for the intensity of magnetization, we can use this H B by mu naught minus H. That will give us I,
Yes, ma'am.
right? First put that heading, otherwise you'll forget to put. Third will be equal to B naught by mu naught minus. Okay, so this we've already got. B naught is 8 pi into 10 to the power minus 4. This is 2 pi into 10 to the power, sorry, 4 pi into 10 to the power minus 7. Minus h, we've got in the first part 2000. Minus 2000. So this makes it 2 into 7 goes up 3. That is also 2000 itself, right? 7 goes
Yes,
up,
ma'am.
that is also 3. And this is to 2000 minus 2000. Here it is C. Got it?
Ma'am.
Write it down and start practicing this chapter also. Okay? Write it.
Yes, ma'am. Can you scroll down? Can you scroll down? Can you scroll down? Ma'am, can you scroll down? Done.
Are you done?
Yes, ma'am.
Okay. See, now I'm coming to the materials, classifications of material, but I'll tell you first based on susceptibility and mu R. Okay. And regarding the different types of material, I'll give you a proper typed document. That's not completed. Otherwise, I would have given you in advance. I'll just complete it by tonight or tomorrow. So
Ma'am.
before you have our next class with me, I'll then take this classification part. So because you don't have to then write that, and because you have to learn it a lot in that. So try to learn it from it. Explanation part I'll be doing here. See, when we are talking about this susceptibility and mu R, for diamagnetic, when you have diamagnetic substances, in diamagnetic, as I've already told you, and we have already discussed that unpaired electrons are completely paired up, right? So they are weakly repelled by the magnetic field. Whenever the external magnetic field is present, they are weakly repelled by them. Okay, I'll just explain you and I'll give you a list that you can copy, but just understand it from here. Remember, I and H, they are of opposite sign here. Means both. I means your not current intensity of magnetization and magnetic field intensity. Okay, they are of the different values. And regarding susceptibility, it is very, very small. In diamagnetic, these things you will have to remember it by yourself. It is lesser than zero, means it is negative, right? So it is small and negative value of susceptibility. Okay, like 5 into 10 to the power minus 9 and all like this. And what about mu r? Mu r is 1 plus susceptibility. So see, it will be slightly less because 1 is getting added to this number. So since this is so small, on addition of 1, this won't be very huge. It will be slightly less than 1. Okay, slightly less than 1. Okay. Now talking about paramagnetic. In detail, I'll come afterwards. Right now, just understand based
Okay,
on
ma'am.
susceptibility and mu r. When we have paramagnetic substances, for paramagnetic substances, when you're talking about chi, see, this is small, but this is positive this time. Okay, the value is greater than 0, but it is still small. And when we was weakly repelled by the magnetic field, this is weakly attracted by magnetic field. All these things I'll give you in written. Weakly
Okay, ma'am.
attracted by magnetic field. Okay. And see, one more thing regarding mu r. So see, this is 1 plus susceptibility, 1 plus chi, right? So here also this is positive 0.0 something. So it will be just slightly greater than 1. This will be slightly greater than 1. Okay, slightly greater than 1. If you remember, we discussed mu r is greater than, very much greater than 1 in ferromagnetic, and diamagnetic mu r is less than 1. When you had your Biot-Savart law class, I discussed this. I gave an example. You have written it in your register.
Yes, ma'am.
When you'll revise, you'll find this. So coming to again the ferromagnetic. Ferromagnetic, they have the value of this very large. It's very, very, very greater. That's why your mu r is also very much greater than 1. So both the values are greater than 1. So look, diamagnetic less than 1 and negative. Paramagnetic small but positive. Ferromagnetic very much greater than 1. Okay. This is one
Okay, ma'am.
major difference between all these three. Okay, so when we are talking about the diamagnetic, let me just explain you the same thing that we have discussed. Yeah, coming to this classification of materials. Look, what are diamagnetic substances? They are basically weakly repelled. Okay, they are weakly repelled they are weakly repelled. Feeble means weak. So they have very weak magnetization. Okay. While what are paramagnetic
Ma'am.
substances? They also have weak magnetization. But when you have the diamagnetics, when you have the ferromagnetic substances, they have a very strong magnetization. Okay. For diamagnetic substances, when you keep these diamagnetic substances in magnetic field, this way you'll be able to see all the three. Okay. See, when you put diamagnetic substances in magnetic field, they'll tend to move in the opposite direction to the magnetic field. Means your I and H will be in opposite direction to it. For paramagnetic substances, it will be in the same direction to magnetic field. And for ferromagnetic substances also, same direction of magnetic field. This is what I already explained. You feebly means weakly repelled. So they are weakly repelled by magnets. They are weakly attracted by magnets, while ferromagnetic are strongly attracted by magnets. Okay. And see, magnetic field tend to move from a very stronger region to weaker region. This is the region of stronger magnetic field. So they'll tend to move like this from stronger region to a less strong region. And they tend to move from weaker to strong. They also tend to move from weaker to strong. Same thing here. They also move from weaker to strong. And few examples you should remember: copper, lead, these are sufficient, sodium chloride or copper chloride. And here the alloys, alnico alloys or iron, cobalt, nickel, like these. So these should be remembered by you. So these are the classification of materials. I'll give you it in writing in a little proper manner, but just the difference that we have written, let me add those so that you can write all these things together. When we are talking
Okay, ma'am.
about the susceptibility in diamagnetic substances, this is small and negative. Okay, it is small and negative where it is lesser than 1. Okay, this is very, very lesser than 1. So your mu r, which is 1 plus chi, this is also slightly less than 1. Slightly less than 1 means mu r is less than 1. Coming to paramagnetic substances, here also this is small but positive, small and positive. Okay, so here also it is lesser than 1 only, value of chi. And when you're talking about mu r, which is 1 plus chi, this is just slightly greater than 1. Slightly greater than 1. Mu r is just greater than 1. Here it was lesser than 1. Here it is just slightly greater than 1. Here it's very obvious. This is very much greater than 1 and mu r is very much greater than 1. Okay. Now you write this
Ma'am.
in a tabular form. This will give you a quick
Yes,
revision,
ma'am.
but I'll give you in detail in written. Okay. By tomorrow you'll receive
Yes.
it. Please write this first. Make it
Okay,
in a
ma'am.
tabular form with a scale and a pencil. Okay.
Okay, ma'am.